So بالنسبة لل second derivative إذا بدي أعمل approximation هذا لل second derivative how should I proceed؟ خليني أكتب أرنيكم شوي على اليمين هون. إذا أنا بكتب إذا أنا باخد مثلا f of أطلع شوي بالطالع f of x plus h again using Taylor هي f of x plus h f prime of x plus h squared f double prime of x he did double prime over factorial 2 plus h3 over factorial 3 f triple prime of x. خليني بس ظبط هي لما يصير في confusion هيدي لكان double prime plus etc. هلا إذا بيجي بقول f of x plus 2h باخد 2 step لقدام بيطلع هي f of x plus 2h f prime of x plus 4h squared over 2 f double prime of x plus 8h3 over factorial 3 f triple prime of x plus etc. So أنا هدفي أوصل لل f double prime. لأوصل لل f double prime يعني بدي أجرب أكيد using f لأنه أنا اللي بيكون عندي إياه هو data points هو عندي y1 y2 y3 يعني yi plus 1 yi plus 2 etc. عندي الوايز وعندي الاكسس بس ما عندي الاف برايمز. So أنا بدي استعمل هول الافات لجيب الاف double prime. So to calculate f double prime we should eliminate f prime in these two expressions. To eliminate f double prime what should we do؟ أكيد حزرته. We should multiply the first one by 2 sorry by 4 and then subtract the second one. Okay, so we multiply the first one by 4 times and then we subtract the next one. What will we have? Sorry, I was thinking about f double prime to eliminate. I should eliminate the f prime, so we should multiply by 2 only. So if we multiply by 2 and then we subtract the next one, we will have 2 f of x plus h minus f of x plus 2h equals 2 f of x minus f of x plus the f prime, this term will vanish لكن plus 2h squared over 2 which gives h squared minus 2h squared, so it's minus h squared f double prime of x plus something of the order h3. Okay, then f double prime in this case of x will be equal to 2f of x. Immediately it's f of x it's 2f minus f, it's f of x minus 2f of x plus h plus f of x plus 2h, and it will be divided by h squared, which is the term coming from here. Okay, plus the order h3 will be divided by h squared as well. It will be something of the order h. So if we consider that this expression is the approximation of the second derivative, it will be an approximation with an order of h. That's why we will give this form which is in here. Okay, so writing two Taylor expansions and combining them, we have an approximation of f double prime with an order h. And if we go back to here, this will give us the same expression. So of course what we are doing here, we are using two Taylor expansions with h and 2h, yani we are doing an explicit approximation. So this is what we call the explicit approximation of the second derivative. So this explicit approximation will be given in this first form in here. Okay, so it's yi plus 2 minus 2yi plus 1 plus yi. So it's f of x minus 2 f of x plus h plus f of x plus 2h. Of course, f of x plus 2h, it's the yi plus 2. Okay. In other terms, if we take an example, if we have xi and yi, 1, 2, 3, 4, whatever, and then 3, 5, 6, 8. Okay, so the second derivative at the point 1, the explicit one, will be, or the second derivative will be approximated by the explicit approximation, which will be yi plus 2. If we take h equals to 1 in this case, so we have, this is the first point, this is the yi plus 1, yani f of x plus h, and this is the f of x plus 2h. So it will be yi plus 2, which is 6, minus 2yi plus 1, yani 2 times 5, plus 3 over h squared 1 squared, and this will be the approximation of the second derivative. Okay, the same, we can do the same to calculate the an approximation of the second derivative using the implicit approximations. Okay, using the implicit approximations, we will proceed, we will apply the Taylor expansion for minus h and minus 2h instead of h and 2h, and we will have something similar to the expression with the explicit and the centered as well, but this, to make the centered, we will use f of x plus h and f of x minus h and combine them to obtain this kind of expression. Okay, and we can notice that in the explicit and the implicit approximations, the approximations are, or the error is of order h, but in the centered approximation the error is of order h squared. Let me go back to the page before and show you this result in here. This is in fact the theorem that I showed in the beginning of the chapter, and that I said that I will come back later to this theorem. Now it's the time maybe to come back to it. This theorem, it states that if you want to calculate the first derivative, you will use a first order divide difference. If you want to calculate a second derivative, you will use a second order divide difference, and this is a second order divide difference. It's xi plus 1, xi plus 2, which is the second order divided difference. Yani in other terms, it's yi plus 2 minus yi plus 1 over xi plus 2 minus xi plus 1 minus yi plus 1 minus yi over xi plus 1 minus xi, and all divided by xi plus 2 minus xi. If you make some manipulations on this expression, you will obtain the same approximation that it is in here, which is yi plus 2 minus 2yi plus 1 plus yi over h squared. Okay, so this can be applied as well for the implicit approximation and the centered approximation. So again, we can go further and calculate. So this is the centered, I said, and then we can go further and calculate the Richardson extrapolation operators for this kind of approximation. Okay, so if we go to the Richardson extrapolation, we will be able to improve the order of the method. If we denote by psi h the first order approximation, the first order centered approximation of f double prime. Okay, let me point out that we will be doing the Richardson extrapolation only for the centered approximations when we are talking about the second derivative. So in the same case of the second derivative, we'll consider only the centered approximation to improve our approximation with the Richardson extrapolation. So if we write f double prime as psi h of f, which is the centered approximation, plus an error order of that starts by h squared, and then again with psi to h, you are used now to this kind of expressions, plus 2h squared in here, and then we combine both to remove the term in h squared, you will have an approximation with an error term of h to the power 4. And this approximation is obtained so using psi h and psi 2h, which are the centered approximations using a step size h and then a step size 2h. And this is what we call the first order extrapolation given in here. So if we want to write down a general formula, I will show it to you, but right before I will just memorize that if we used a first order extrapolation, our error is of order 4, a second order it's of order 6, third order extrapolation the error will be of order 8, etc. And to write down a general expression for the centered approximation, it will be given as the one we obtained before with to the power 2k, or simply we will not go more than the second extrapolation, which will be given in this expression here. Okay, so the next video will be talking about the finite differences method, which is the main interest of this chapter.